Okay, so once again, good morning, everyone. Welcome to um, TIMO mock review 2025-2026 for the secondary 2 level. Um, okay, first part will be on logical thinking. Number one, find the average of the following sequence. So today, not today, but for this number, what we need to consider is we have to first verify what kind of sequence do we have. So we can consider, hey, this is like what? You just plus, right? Just add numbers. So as you can see, we have 5 plus 7, so probably just 12, right? So we have a common difference of 12. So yeah, that still works up until the end, and then the numbers at the end of the sequence. So since we know that everything is just 12 in between, all you have to do is just take like the first and the last numbers, find the average, and we're done. Okay. So the first number is five, -5. The other number is positive 475. So actually, it's even better to write it this way. So the average is just the total divided by how many are they. But in this case, again, we're just going to consider first and last ones, which means you only have two numbers. So that will be what? 470 divided by 2, which will be in turn 235. Is this okay? Any questions for number one? Okay. All right. Let's go to the next one. Number two. Number two, there are 15 white table tennis balls, 27 orange table tennis balls, and 12 blue table tennis balls mixed together. If we randomly choose table tennis balls without replacement, how many table tennis balls must we choose to ensure that we have at least five white table tennis balls and three orange table tennis balls? So what we need to consider here is the worst case scenario. So when you say worst case, that's basically like when you're unlucky. Okay. You want to get five white balls and you want to get three orange balls. So again, you have to consider worst case. So worst case is whenever you don't get any white and orange first, right? So that is when we just pick 12 blue. So that's 12 blue. Is that okay? And the next thing will be considering which is bigger, 15 or 27. So obviously 27 is bigger, which means you're going to get all the 27 orange as well. So plus 27 orange. So when we have 27 orange, this is already satisfied. So no need to consider this. And then finally is just the plus 5 white. So this is what we call the worst case scenario. Okay, when you're unlucky. You want to get 5 white and 3 orange? No, you're unlucky. So instead we get 12 blue, 27 orange, and 5 white. So adding them all up, 12 plus 5 is 17. 17 plus 27 is 44. So yeah, 44 balls. Is that okay? Any questions? Okay, never mind. I'm not gonna ask if there are questions. Okay, I'm just gonna look at the chat. If there's no questions, then I'm just gonna proceed. Of course, we can just go back to the previous numbers if you guys have like a late response to the question. Okay, number three. Robert goes 47 kilometers north, 47, and then goes 16 kilometers east. Where's east? Probably here. 16. Finally goes 17 kilometers south. 17 or something. How far is he now from his original position in kilometers? So basically, if this is like the the final position, right? This is starting. So what you have here is actually a right triangle, okay? Where this base is given by 16 And then this height here is given by 47 minus 17, which is 30. Is that okay? So all you have to do is actually just consider the hypotenuse of this right triangle. That would be also the answer. So by Pythagorean theorem, you have c squared equals, actually, yeah, c squared equals a squared plus b squared, which means c is just the answer what you want. Take the square root of a squared and b squared. So that's 16 squared and then 30 squared. Okay. So 16 squared, this is 256. Hey, you guys are secondary too, okay? You guys should familiarize your squares. 16 squared, again, 16 times 16 is 256, and then 30 squared is 900. And then, what would this be? 900 plus 256, that would be the square roots of 1156. Okay? Which is in turn, hold on, I'm just gonna move everything. Is okay, I need space. And then, yeah, the square root of 1156, again, you guys must know your squares already. Up until 50 is possible, if possible. This is 34 squared. Square root of 34 squared, which is just 34. Okay. Also, if you also notice, if we have like 16 and 30, so when you consider like Pythagorean triples, these are numbers that always follow this pattern. C squared equals a squared plus b squared. So if this is your a, this is your b. Also again, this is just following the pattern of 8, 15, 17. Okay. So 8, 15, 17 is a commonly known Pythagorean triple. And then if you consider 16 and 30, these are just multiples of 8 and 15. Okay. This is when we multiply both of them by 2, which means, of course, the last one will be 34 because that will be 17 times 2. Okay. So yeah, this is also like another way of solving this problem. So no questions on the chat. So yeah, let's just go to the next number then. Number 4. Okay, this is a bit lengthy, but here we have to establish the ratio A, B, C, D, E. Okay, so first you have to deal with the A, B, and B, C first. So A, B, and then B, C. So we know that A is 5, 6, and then B, C is 2, 3. Okay, so we just want them to like get the least common multiple of the common letter. So between 6 and 2, well, we can just consider 6, right? Which means 5 just stays as 5, but on this part right here, 3 must be multiplied by 3. Okay, because for 2 to get to 6, you have to multiply 2 by 3. So which means you have to multiply 3 by 3 as well. So this is now our new ratio, 5, 6, 9. So this is for ratio A, B, C. So as you can see, AB is still 5 to 6, and then BC, which is 2 to 3, that is still the same with 6 to 9 because we can still make it simplify it into 2 to 3. Okay, so we can check that later. Okay, so just remember 5, 6, 9. So we have 5, 6, 9, and then we have next for CD will be 6, 7. Why do I have to say it like that? 6, 7. Okay. Now we have to consider again like the common multiple of 9 and 6. In this case, that will be 18, right? So for 18, the numbers here, like 5, 6, 9, you have to multiply them by 2, okay? Because 9 times 2 is 18. So which means for 6, that would be 12. And then for 5, that would be 10. And then for here, like these numbers, you have to multiply by 3. Okay, 6 times 3 is 18, which means 7 times 3 is 21. Okay, so again, if you want to check, this will still follow like the usual fractions, the usual ratios. So this is still 5 to 6. This is still 2 to 3. And then this is still 6 to 7, 6, 7. Okay, and then finally we have 3, 3, 1. Okay, so I'm just gonna remove some of these. And then 3, 1. So as you can see, least common multiple of 21 and 3 is just 21 still, which means everything on top will just be copied. 12, and then 10. Okay. And then for the last number here, we have to multiply it by 7 because you need to multiply 3 by 7. 3 to 7 so that you can get 21. So 1 times 7 is just 7. Okay. So now this is actually our new ratio for A, B, C, D, E. A, B, C, D, E. And then also from the given, A plus B plus C plus D is plus E is 1972, which means that for some number X, say we have like something. So we know that A is represented by 10X, okay? B is 12X, 18, sorry, C is 18X, and then 21X, and then 7X. So when we add them all up, not really sure what this is, but this is 28, this is 30, and this is 10. This is 40, that's 68. So that's 68X equals 1972. All right. So all we have to do now is solve for X first. You can write it over here. 1972 divided by 68. Probably 3, right? Because 60 and times 3 is 180. So 3 times 68, that'll be 24, 60, 18. It's 204. Okay, so that's impossible, which means you just have to have 2 instead. So 2. 2 times 68 is 120 plus 16, 136. Subtracting 1612. So this is 68 times 10 is 680, right? So this is fairly close to that one, so which means it's been 9. 9 times 8 is 72. 6 times 9 is 54 plus 7. So yeah, 612. Okay. So our X is 29. So X is equal to 29. Now the question was find the value of D minus C. D minus C. So from the given ratio, now from the ratio that we've established, we're going to look at D minus C. So D minus C is the same as 21X minus 18X. Okay. So when you subtract these, we have 3X. But again, X is 29. So we have 3 times 29. And so the final answer must be 87, right? 87. Is that okay? Do you have any questions? Okay, so let's go to the next one, number 5. Okay, so this is the this is a bit this is easy, but it's kind of like not that obvious. Okay, there are 300 parts in a batch, one of which is defective, which means the defective part is lighter. When you say lighter, it weighs lesser than the usual weight. Okay, lighter than the good part. Using a balanced scale, how many weighings are needed to guarantee that the defective part will be found? So the thing about using a balance scale is that you can actually get 3 things, right? You can determine which one is lighter, which one is heavier, and when they're like equal of weight. So you have these 3 results. You can say which one's lighter, which one's heavier, or whenever they're equal as well. So knowing this, what we want to do is actually there is already a formula for solving these kinds of problems. That will be 3 to the n minus 1 uh less than or equal to n less than or equal to 3 to the n. Okay? So your n here in this case will be 100. All right? So that will be 3n minus 1, 100, 3 to the n. Which means our answer is this guy, like n. So which means we're just comparing, we're just considering powers of 3. So the powers of 3, we have 3, 9, 27, 81, 243, and so on, right? But again, we only need to consider like 100 because we only have 100 parts, which means we can get something like 81. Okay, 100 is between 81 and 243. And then again, We're just comparing powers of 3, which means 81 here is 3 to the fourth power, and then 243 here is 3 to the fifth power. That is why the answer is 5. Okay, so the answer is 5. So, if you don't know this formula, I'm going to show another solution. Is that okay if I'm going to show that? Thumbs up. Okay, I get one thumbs up. So let me just thumb up. It's only one. Okay, there we go. So if you don't know what to do here, like if you just think about it or to do it rationally, what you want to do is, again, you have to consider three things, right? Lighter, heavier, and when they're equal of weight. And they're of equal weight. Okay, so what you're going to do is you're going to divide 100 into three parts. Okay, so which means you're gonna have like 100 divided by 3. Come on, that's 33.33333, right? We cannot have that. Okay, so instead we're gonna have three groups. One that is 33, another that is 33, and then another that is 34. Is that okay? And then what you want to do is you're going to put on the balance scale these two 33s together. Like one is 33 and then the other is 33. So obviously they should be equal, right? Because they're of equal number. However, if this guy is like heavier, which means if this guy is heavier, then this one is lighter. So this one's, wait, what? The heavier must go down, okay? Right? When you consider the scale, the heavier thing, no. The heavier the thing is, it's gonna go down on the scale, right? So if this 33 goes down on the scale, which means this will be heavier. And then if this goes up, this will be lighter. Which means if this goes up, then the defective part is in this group, right? Okay. So you're going to consider that one. So if they're equal, if they're of equal weight, like 33 and 30 are equal, then you know that the defective part is in here, like in 34. Okay, so as you can see, um, either way, we can just divide them again by 3. Okay, divided by 3, this is just all 11s, 11 as well. And then this is 11, 11, 12. And then you're going to repeat the same thing. Okay, you're going to repeat the same thing, which means you're going to put this on the balance, okay, or these guys on the balance. Sorry, not that one, but always the equal ones. Okay, that way you can determine which one has the defective part. Okay, so when you do that, of course, 11 divided by 3. So you can get what, 443 again. So this 443 here, 443, 443, 443, 443. Just in case, okay? Just in case, whichever of these has the lighter part. Oh, sorry, the defective part. But for 12, this will be 444. Okay, and then you weigh it again afterwards. Okay, you weigh the equal ones. 4 4 4 4 4 4 4 4 4 4 4 4 4 4 4 4, and then again that will tell you which one has the defective part. And then afterwards you're going to divide again by 3. So this will what? This become 211, 211, 111, right? 211, 211, 111. So as you can see, how many times did we weigh? Okay, so we are actually weighing them 5 times. Okay, for the last one, like in here, you can now tell which one is the defective part. Okay, so first, second, third, fourth, and then 5. 5 weighings. Is that okay? Are there any questions for number 5? So again, for the next time, just consider the formula. It's way, way easier. So probably no questions. Let's proceed to number 6. Where is the 5? Okay, so the 5 here is, again, we're just counting how many weighings, right? Or how many times did you weigh them? Okay, so again, this is the first time that you weighed them, 1. So this is the second time, third time, and then these guys will be the fourth time, and then the last one will be the fifth time. So there we go. There's 5 that we're looking for. Is that okay? Yeah, no problem. How if there are 2 defective? Now that's tricky. two defective. Probably just double then, right? Because first you need actually that's oh yeah, it's actually going to be different. Because if there are two defective, if you go back here, right? Let's go back to the very beginning. Hold on, I'm just gonna clear stuff. So earlier the logic was look for the one that is not that's odd, right? For example, you have to consider always like the numbers. Okay, for example, um we're going to weigh these guys together because we know that they should be equal, right? So if they should be equal, then uh if one of them has a defective, yeah, it's kind of hard to do two defectives. Okay? Because what if like this guy has one defective, also this guy has one effective, then obviously they're still gonna weigh the same. Does that make sense? So I don't think this works. Like the idea here works. So don't worry. Um, since that idea doesn't really work, then these types of questions will only have only what? Only one defective part. Okay? So yeah, I think that's it. Because if it comes to, then it's a bit more difficult to analyze. Okay, it's a bit more complicated. So probably instead of dividing it by three, maybe you just divide it by two then? No, I think by three is always better because again we have to consider like whenever they equal. So yeah, I think they'll always divide them by three again. And then put them together. And if they're equal, then you can say that hey, maybe this guy has the two, right? Or this guy has the two, or each one of them, like 33 and 33 have one the same. So I think you can just maybe the answer here will be 10, you know, like just double. But yeah, I don't think there will be the case where it's gonna tell you that's gonna be two defectives. Okay, number six. There are four people, A, B, C, and D. Each person either always tells the truth or always lies. Says B lies, B says C tells the truth, C says D lies, and then D says A tells the truth. Interesting. What is the minimum number of people who are telling the truth? Okay, so since yeah, this is just true or false, right? A could be true or false, B could be true or false, C true or false, D true or false. Okay, so we're just going to consider two scenarios, okay? For one person. For example, if A is telling the truth, is that okay? So something like A, B, C, and D, true, false. Is that okay? So we're gonna have this table. So if A is telling the truth, what will happen to B? If A is telling the truth, then B is lying, right? So B is lying. I guess that's the truth. B is lying. So if B is lying, then C is also lying because C tells the truth. And then if A is telling the truth, then A is telling the truth, which is just a statement of D, right? Is that okay? And then we can actually do the same thing, like whenever A is lying. So if A is lying, then of course that'll be false, which means B is telling the truth because it says that B lies. And if B is telling the truth, then C is telling the truth. If C is telling the truth, then D is lying. Does that make sense? So as you can see, either way, like the minimum number of people is just two. Okay, it's either A and D, or it's either B or C. So the answer is two people, or minimum number is just two. Does that make sense? I hope it makes sense for you guys. Okay, so let's go to the next one. There are no questions. Okay, yeah, so now we're on to algebra. 3x minus 2y equals 7, 2x plus 5y equals 30. Real numbers x and y, find the value of y. Okay, so since we're looking for y, let us eliminate x. Is that okay? Because we want y. We don't want x. So we just consider what do we need to multiply, okay? For both of these equations so that we can eliminate x. So we can multiply this by 3, and then we can multiply this by 2. That way, we're going to have something like 6x minus 2y equals 14. And then the other would be something like 6x plus 15y equals 90. And then we subtract one from the other. So other way around is better, like 6x plus 15 y equals 90. And then we subtract the other one, say minus 6x. Um, Subtract meaning just going to multiply the whole thing by a negative number. So negative 6x plus 2y. Oh wait, hold on. 2 times 2 is 4. So this should be 4. This one. Okay, 4y. And then negative 14, so minus 14. 6x minus 6x is just 0x. 15y plus 4y is 19y. And then this one is 90 minus 14 is 76, which means y must be equal to, so we can just divide both sides by 19, and then we get y equals 4. Way too straightforward, right? It's not much. Any questions for number 7? Probably no. Yeah, let's go to the next one. Number 8. Find the value of real number x if x is what? If x minus 4x over 9 equals 35. Okay. So I think this is easy. We can just first factor out x, right? When you factor out x, you're gonna have something like 1 minus 4/9 equals 35. And then 1 minus 4/9 is basically what? 5/9 equals 35. And then we multiply by 9. Everything multiply by 9. Actually, you can just multiply everything by 9/5. That way you can just cancel 5, cancel 9 as well. Then here multiply 9/5. So x equals 35 and 9/5. We can cancel 5 and 35. We get 7. So x is 7 times 9, 63. Is that okay? Um, Morgan Co., you're raising your hand. Go ahead
Sir,
and
I have a question.
yeah, what's up?
What happened to the fraction bar between 4x and 9? What
4x and 9. Oh, this one.
what happened to the fraction bar?
Oh, fraction bar. I think it's just I don't know. I just took a screenshot of the stuff, like of the questions.
Oh,
Okay. So this may be, and then
okay.
yeah, this should be like a connected. So yeah, sorry about that. Not my intention to cut the bar, but yeah, it is a fraction, right? It's a 4x over 9. Is that okay?
Yes, sir.
Okay, thank you so much for asking that, by the way.
Look,
Yeah, no problem. Okay, any other questions? Secondary two, wait. I'm just imagining, for example, like the fraction was missing like a part, right? So it's like for me, it looks like missing a tooth or something. So you guys in secondary two, probably you guys don't have a missing tooth, unless like someone punched you, or I don't know. That's bad. Okay. I have a missing tooth. I lost mine. It's not really, yeah, it's in the back. Not really. Can't be seen that easily. I try not to. Okay. No questions? All right. Let's go to number 9. Find the sum of all possible values of real number x if the absolute value of 2x plus 12 minus the absolute value of 7 minus x equals 99. So this is like absolute values, which means we're going to consider two things for each of them. That is when, for example, 2x plus 12 is positive or negative, and at the same time when 7 minus x is positive or negative. Um, so we're gonna have four cases in total. First case will be case one. Case one will be when both of them are positive. Is that okay? So both of them are positive. So 2x plus 12 minus 7 minus x equals 29. So 2x plus 12 minus 7 plus x equals 29. Um, what do we have here? 3x plus 5 equals 29. And then 3x equals 24. So x is 8. Is that okay? Also, we have a second case, case two. Oh, wait, hold on. After each and every x, you have to try it if it works. Okay, for example, 2 times 8 plus 12, absolute value, minus absolute value of 7 minus 8 equals 29. So it should be equal to 29 for us to consider that x. Is that okay? So this is 16 plus 12, and then this is negative 1 equals 29. So 16 plus 12 is 28, right? 28 minus, oh no, it doesn't work. So the absolute value of negative 1 is 1. So 28 minus 1 is 27. So when you say 27 is equal to 29, that's no. Okay? Impossible. I can't read your name, Blackjack. What's up?
I'm sorry, but you can slow down a little bit.
Sure, sure. Yeah, sorry about that.
Okay.
No problem, no problem.
Sige.
Okay. Again, after each and every case that we consider, okay, we're going to try out the x that we get. So, for example, here we tried out x equals 8. Um, when we did that, obviously, we cannot have 27 equals 29, right? So, unfortunately, for this very first case, we cannot use x equals 8. Okay, so let's try again. Let's consider case two. So case two is whenever um, the first one is positive and then the second one is negative. Okay, so first part is positive, so 2x plus 12 minus negative of 7 minus x. 7 minus x equals 29. Okay, so 2x plus 12. So take note that we have here two negatives, right? Two negative signs, which means you can just make it into a positive sign. Aguilar, what's up?
Isn't it impossible for the absolute value to be negative? Like, absolute value is always positive, diba?
Yeah, when you say absolute value, it's always positive. However, since we're doing like operations between them, does that make sense? So we have to make sure first what will happen. Okay? Like if it's negative or positive. Does that make sense?
Mm, okay, thank you, sir.
Yeah,
But but when it's absolute value to
it should
find,
be
it's
positive. Yes, it should be positive.
positive.
Yes.
Okay, thank you.
Because here we're just solving for x, okay? No, because since we're solving for x, we have to consider what happens. Because sometimes when x is positive, okay, or when x is negative, it can get real fun, real confusing as well. Okay, going back here, you have two negative signs, which means you can just make that into positive sign, right? And then 7 minus x equals 29. Um, 2x minus x is x. 12 plus 7 is 19 equals 29. And then from here, we can subtract 19 both sides. 19, 19, which means x is equal to 10, right? So let's actually try out if 10 works. So 2 times 10 plus 12 absolute value, and then minus 7 minus 10 absolute value, 29. Okay, 2 times 10 is 20 plus 12. This one's 7 minus 10, so that's -3. 20 plus 12, 32. Minus absolute value of -3 is just 3. So yeah, I think this works. 29 is equal to 29. Yeah. So we have the first value of x, say 10. Is that okay? Just going to remove everything first. Okay, so 10 works. Is that okay? Let's consider case 3. I'm just gonna remove this one first because I wrote this one first, right? Case 3 is whenever, I don't know, both of them are negative. Okay, so when both of them are negative, we have negative 2x plus 12. Minus negative of 7 minus x equals 29. So negative 2x minus 12. Two negative signs such as positive 7 minus x equals 29. And then negative 3x minus 5, right? Negative 3x minus 5. Yep. Equals 29. And then 29 plus 5 is 34. Negative 30, negative 3x is 34. Which means our x is negative 34 over 3. Do you want to use that? You have no choice. You have to put it in. It's kind of weird, but hey, it's math. Just remove these ones, I guess. Because these ones are the one that is changing. Okay. Negative 3/4. Sorry, negative 34 thirds. So that's 2 times 34, so that's negative 68 over 3. Also, 12 is just what? Of 36, right? 36 over 3. So you can just use that as well. 36 over 3. And then here, 7 is 21 over 3. And then negative 34 over 3. Two negative signs, which means that's just a positive 34 over 3. Okay, let's go back here. This is what? Negative 68 plus 36. So that's negative 32 over 3. And then on the other side, we have 21. 21 plus 34, that's 55, right? 55 over 3. Okay. And then 32, and they're both negative numbers, so we can just add them up. That's 87 over 3. Okay, so they're both negative, but our 29 is a positive number. Wait. Hold on. Oh, okay. I think I missed this one. So I missed the absolute value. Okay. This one, absolute value, never mind because you have a negative sign outside. But on the first one, since this is an absolute value, then it should become positive, right? So we're gonna have something like positive 32 minus 55, which is still weird, by the way. This should still be a negative number. So that will be what? Negative 23? Negative 23. But yeah, either way, it's a fraction. So it's not 29 as well. So again, we cannot use this one. Okay. And then the final case would be if this one's positive. Supposed to be plus x, not minus x on the second line. This one right here. I'm canceling negative and negative here. That's why I just remained it to be negative x. Does that make sense? I just removed both of them, because they're both next to each other. So that's why it's still negative. Okay. Yeah, again, last case will be whenever we have case 4. Case 4 is minus plus. So this one's minus, this one's a plus. So if that's minus, then this will just be the same. But if this one's a plus, then maybe I can just remove 1, something like that, right? So it becomes what? Negative 7 and then plus x. Negative 7 and then plus x. And then negative x. Negative x minus 19, which means we're going to add 19 both sides. So x equals what? Negative 48, right? Sorry, I'm still using shortcuts. But yeah, negative x equals positive 48, and then we divide both sides by a negative number, which means x is negative 48. Negative 48. Bro, it's not writing properly. I do not understand. Negative 48. There you go. So we have that one, which means we're going to replace the entire fractions here as well by negative 48. Okay. Actually, it's just better to just remove everything, right? Negative 48, negative 48, negative 48. We have 10 earlier. We're going to try negative 48. So that's 2, and then 2, and then negative. Bro, it's not writing immediately. 48 plus 12. Hold on, I think I need to do something. It's too laggy. What else can I close? Okay, I cannot exit Zoom. I'm using Zoom. Okay. Plus 12 absolute value minus the absolute value of 7. Dude. 7 minus negative 48 equals 29. Okay. So first one is negative 96. It's too big. Plus 12. Absolute value minus 7 plus 48 is 55. 96, 84, right? So this is 84 minus 55. Bro, I don't know why. 55 equals 29. So what's 84 minus 55? It's almost 30 away. So yeah, it is actually 29. 29. Okay, so our x here was negative 48, right? And so we're looking for the sum of all the possible values. So just add 10 and negative 48, which means the answer is just negative 38. Is that okay? Negative 38. Questions? Okay, so no questions? Okay, so let's move on to the next one then. No questions, right? So number 10. Number 10 is factoring. So there's actually a lot of ways to do this one, but I think the faster way is just dividing them by 2 first. So divide by 2, which means you're gonna have some. It's still lagging. Hold on. Can I do something? Wait. I'm gonna try and end the share first. Is that okay? I'm going to stop the share and then I'm gonna come back again. It's too laggy. I don't know why. Okay, you guys can see my screen, right? All right. Okay. So again, just factor out 2 first. X squared minus 9y squared plus 10x plus 25. Is that okay? After factoring out 2, we can rearrange them. For example, x squared minus 10x plus 25. And then you also have like minus 9y squared. Is that okay? And then from here, it's actually, we can actually see like 2 square numbers or 2 square polynomials. So the first one is this group, say x squared minus 10x plus 25. So this is one square, right? This is a square number. And then on the other side is also like a square number, say 9y squared. Is that okay? Equal sign, equal sign, equal sign, equal sign. So this one here is what? X minus 5, right? X minus 5 squared. And then on the other side, we have like 3y squared. Is that okay? Someone's raising their Ethan. What's up?
Sir, why did the 10x become negative, sir?
Oh, sorry, my bad, my bad, my bad. So it should be positive, right? Okay, so positive 10x, which means it should be a positive 5 as well. Okay. Yeah, thank you for noticing that. I did not notice it. I was just looking at this one and then just copied everything. My bad, my bad. But yeah, the idea stays the same. It's still a square number. You're still raising your hand, Ethan? Okay, okay. So I thought you had another question, but yeah, okay. I hope that's okay now. So next will be actually, hold on. Just move first. Oops. 9y squared. Okay. So next will be, so take note that this is what? A difference of 2 squares, right? The difference of 2 squares, the square of x plus 5 and the square of 3y, which means we can further change it into something like x plus 5 plus 3y, okay, times, hold on, x plus 5 plus 3y times x plus 5 minus 3y. Is that okay? And then we can simplify it further, say 2 times x plus 3y plus 5. And then on the other side, we have x minus 3y plus 5. And then we're done. That's the answer. You have now factorized it completely. Any questions? Is it x plus 3y? Yep, that's correct. That's the same thing. So all you have to do is always familiarize your special products, right? So if you don't familiarize yourself with special products, you're gonna have some trouble, okay? Which means you're gonna like have more time to do this. Okay. Number 11. So given 3x minus y, x 3x. Okay. Is this? It's almost the same question with the previous one, but here we're actually looking for the value of. Wait, hold on. I think it should be a value of x. Yeah, this should be value of x. My bad. So if you're looking for the value of x, now we're going to get rid or eliminate y. So when we eliminate y, we can just multiply this one by 5, and then we can multiply this one by 2. Is that okay? For the first one, that will be 15x minus 10y equals 35. And then for the second one, that will be 4x plus 10y equals 60. So we can just add them all up immediately because our y's here have already negative and positive signs or opposing signs. So 19x still. This becomes 0, and then this is 95, right? And then when we divide them by 19, we will get x equals 5. Is that okay? Questions? So again, it's pretty straightforward. Let's try and look at the next one. Number 12. Find the value of this term times this term minus that term times that term. So the thing here is we have to consider which part is like we can simplify. Okay, not really simplify, but we can substitute for. Like for example, if you look at each of the terms, all of the terms have 1/2 plus 1/3, okay, up until 1 over 2024, right? This ends at 2024, this ends at 2025, 2025, 2024, which means all of them has this one. Is that okay? So we're going to take, I don't know, if you want x, sure, we can let that as x. That way we can have something like the whole thing as the first one is just 1 plus x. And then the second one is just x plus 1 over 2025. Is that okay? And then on the other side, we have 1 plus x again. And then actually, well, no. This is 1 plus x plus 1 over 2025. Is that okay? And then the last one is just x. Is that okay? Again, so just look for the common term, substitute x for it. And then we can just proceed. So here we can just distribute 1 to both of them. So we get x plus 1 over 2025. And then we distribute x again to both of them. You'll get something like x squared plus 1 over 2025x. So this is the first group. And then the other one, just distribute x to all of them. So that becomes what? X plus x squared plus 1 over 2025x. And then we just remove the common terms because we're subtracting, right? So for example, this one and this one, they're going to cancel each other. Is that okay? They're the same terms, and then you're going to subtract them. X squared and x squared, gone as well. X and x, also nada. Which means you're just left with 1 over 2025. And we're done. The answer is 1 over 2025. Any questions? No questions. Okay. Let's go to the next one. Number 13. Hold on. Okay, so I'm sorry about that. Someone was calling. With the mock test and the recording be sent or emails? Yeah, it should be. As long as like everyone on our end has like uploaded the videos and stuff, it will be sent to you. Okay. Okay. Wait. Yeah, okay, number 13. Find the unit digits. So when you say unit digit, that's like the last digit, right? Last digit. Okay. Of this one. 1 plus 7 plus 24. Okay, lucky for us, it's giving us like the the actual pattern. So which means it's gonna start like, I don't know, 3 to the 1, 3 to the first power minus 2, right? 3 to the first, yeah, that's equal to 1. So that's just 3 minus 2, which is equal to 1. 3 squared minus 2 is 9 minus 2. So again, that's just 7. Okay. So now that we know that, all you have to do is just add, right? 3, actually, the summation of 3 to the n from n equals 1 up until 9. And 3 to the n minus 2. Is that okay? What's up, Aguilar?
Sir, isn't that should the 24 be 25 because 27 minus 2 is 25?
Oh, yeah, good catch. Hold on. Let me check the question list. Probably a typo on my end. Hold on. What number is this again? Number 13. Number 13, number 13. It's 24. But yeah, anyway, yeah, good catch. I'm going to take note of that as well. Number 13, 24 should be 25. Number 13. 24 should the third term, which is 24 should be 25. Okay. Yeah, thanks. Because that would be weird, right? If this one is not following instructions, not following the usual pattern of 3 to the n minus 2. Yeah, this works. Okay, thank you for that one. All right, now where were we? So now all you have to do is, how many terms do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 terms, okay? So we have something like summation of n equals 1, 3 to the n, 9, minus summation of n equals 1, 1 to 9 of positive 2. Okay. So here, what we can consider is just that these are just powers of 3. So that's what? 3 to the first power, 3 to the second power, okay? 3 to the third power, 3 to the fourth power. Now take note, I'm writing it this way. 3 to the fifth power, 3 to the sixth power, 3 to the seventh power, 3 to the eighth power, and then 3 to the ninth power. And then here we just had a bunch of 2s. So 2 plus 2 plus 2 plus 2, plus 2 plus 2 plus 2 plus 2 plus 2. So this is all addition because again we're doing summation, right? Wait, that's too much. Too much 2s. Okay. Maybe that's enough. Okay, the reason why I wrote it this way is because again we're just considering what the last digit, right? Last digit. So when you consider like powers or exponents of 3, say 3 to the first power, that's just what? 3. Okay. 3 squared, last digit is 9. 3 cubed, last digit is 7. 3 to the fourth power, last digit is 1. 3 to the fifth power, last digit is still 3. 3 to the sixth power, last digit is still 9. Okay, so there's actually a pattern for that one. That's why I wrote it that way. Still the same with 3 to 9. Is that okay? So this one, all here is just a bunch of 3s, plus 3 plus 3. On the other side, it's just what? A bunch of 9s, 9 plus 9. 3 and 7, both are 7s. 7, 7. last digit of these guys here are what? 1. And then here is just 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if 9 twos, just 18. Okay. And then this one you can simplify easily. 9 plus 18 plus 14 plus 2. This is a 10. Sorry, this is a 20. Okay. And this is 14 plus 9 is 23. So again, we just want to consider the last digit. Okay. So 23 last digit is just what? What's the last digit? Well, what? Am I confused? All right. 1 plus 1, 2, 14. 3 plus 3 is 9. 9 27 plus 2, 29 plus 14. Yeah, 43. 43. Okay. And then 43 plus 18, that's what? 61. Okay. Oh, wait, hold on. We're subtracting. We're subtracting 2. Sorry about that. Which means 18 here, like the entire thing here is subtracted. Okay. So this whole thing is a 43 minus this whole thing is a positive 18, which is just 43 minus 18. It's that 25. So yeah, last digit is 5. Questions? So is this okay? Again, we have to subtract, okay? Don't forget about the negative. No questions. Okay, so let's go to number 14 then. Find the remainder when 19 raised to 50 is divided by 4. So first, let's consider 19, actually. So 19, when we divide it by 4, what's the remainder? We have a remainder 3, right? So that's 3 mod 4. Okay. But when we're considering the modulo, 3 is what? 3 is 1 away from 4. Is that okay? Patricia, what's up?
What does the mod mean? I
Mod
still
means, yeah, mod means just remainder. Okay. So for example, if you divide 19 by 4, say 4, right? 4 is 4, 16. So this is the remainder. Okay. So when you say modulo or mod, it's just talking about the remainder. Is that okay?
okay. Thank
Okay.
you.
Also for since we're talking about mod 4, like specifically mod 4, we only have what? We only have 4 remainders. Okay, we have 0, 1, 2, and 3. Is that okay? So that is why 3 here is 1 away from 4, right? So that's why we can rewrite this -1. Rewrite, okay? Rewrite. So which means that 19 is the same as -1 mod 4. Which means if you consider 19 to the 50, so 19 to the 50th power, that's just the same as -1 to the 50th power. Is that okay? But we do know that -1, especially when raised to an even number, that's just equal to 1. And so 19 raised to 50 will give us the remainder of 1. Remainder. Aguilar?
Right, sir. So what did we do after we got 19 to the power of 50, congruent to 1 mod 4? What did we do after that?
That's it. It's telling us that, hey, 19 to the raised to 50 divided by 4, we're going to have a remainder of 1. Because that's the question. Find the remainder when 19 to the 50 is divided by 4.
Okay, and then sir, what's the what did we divide 19 for?
Well, what was that again? Oh, okay. This one, like for the first step.
Yeah, no, I mean for like the thing on the right.
Oh, the thing on the right. This is
Yeah,
to
the
show
division
like
on the right.
this is to show the remainder that is 3.
Oh, okay, thank you.
Yeah, no problem. Anything else? So as much as possible, especially when we're talking about remainders, modulos, it's always better if we can simplify them into like 1 or -1. Okay? Because as you can see here, like because we know that 19 is congruent to -1, obviously -1 is so much easier to deal with, especially when you talk about its exponents, right? So -1, it's either 1 or -1, or 1 and -1. So it's just that instead of 19 times 19, like what is that? 361. 361 times 19, bro. You're not gonna stop. Okay? So I mean you gotta stop at the 50th times that you're going to multiply. But yeah, the idea still holds. Like it's just a cycle, okay? Cycle of modulos, remainders. Okay, any other questions for number 14? So now hold on. The session will end at 1 p.m. my time. So currently it's 12:20, so we have like 40 minutes left. 40 minutes left for half of the questions. So I'm just gonna pick the speed up. Is that okay? And then the answer is 1. Given by this one. Okay, I'm just gonna clear all the unnecessary shapes. But yeah, this one right here, like at the bottom, that's 1. 1 mod 4. Okay, number 15. If x plus 5 is a factor of a polynomial, define the value of c. So when you say x plus 5 is a factor, then automatically, when we equate that to 0, this will give us a root, which is x equals -5. Okay? So when we have that root, which means the entire thing, say 15x squared plus 70x plus c must be equal to 0 when x equals -5. So let's try that out. 15, we are going to replace x by -5. -5 squared plus 70 times -5 plus c equals 0. So here we just solve for c. Okay, so that's 15 times 25 plus, so this is now what, -350 plus c equals 0. 15 times 25. 250, 325? No, 375, right? 375. 375 plus, actually -350. So minus 350 plus c equals 0. 25 plus c equals 0. C is -25. Is that okay? Questions? No questions? Okay, let's go to the next one. Number 16. How many integral solutions is or are there? Okay. Just going to rewrite everything. 7x plus 19. So here, we want to simplify the term which has x. Okay. So x is on the middle term, which means you have to simplify the middle term. First, let's multiply everything by 6 so that we can get rid of the fraction or the denominator, 6. So this becomes -18, 7x plus 19. And then 39 times 6. I don't know what that is. 40 times 6 is 240. That's 234 then. 234. And then from here, we subtract 19. Okay. Subtracting 19, this becomes -37. 7x. Subtracting 19 here would be 215. And then from here, we divide by 7. So -37 divided by 7 x 215 divided by 7. And then we can simplify. This is what, -5 and 2/7. And then x here. Then this is what, 30 and 5/7. So no need for decimals. Because again, we're just looking for how many integral solutions are there, or how many integers are there between -5 and 2/7 up to 30 and 5/7. So for positive numbers, you have 30 positive numbers, right? From 1 to 30. And then for negative numbers, we have -5 to 1. So -1. So that's 30 positive numbers, 5 negative numbers, and of course, 0 also works. Okay, so that's another number. So all in all, that's 36 integer solution. So yeah, solutions. Any questions? Okay, so I think that's it for number 16. Let's go to number 17. Find the smallest positive number, positive integer n, such that n leaves a remainder of 1 when divided by 2. Okay, so that's 1 mod 2. 2 mod 3. 3 mod 4. 4 mod 5. 5 mod 6. Is that okay? So actually, if you consider everything there, so they're all 1 away from each other. Okay. Like for example, this is what -1 mod 2. This is -1 mod 3. This is -1 mod 4. Everything is -1. -1 mod 5. It's not writing anymore. Mod 5. -1 mod 6. Okay. So we can also say, hey, maybe we can just get like the least common multiple of 2, 3, 4, 5, and 6, and then subtract 1 from it. Is that okay? So 2, 3, 4, 5, and 6. 2, 3, 4, 5, and 6. So this one is just 2, this one is just 3. 4 is 2 squared. 5 is just 5. 6 is 2 times 3. So we actually have to consider what? We have to consider 2 2's, or a square of 2, because that will cover these 2 2's. And then 1 3 times 3, that will cover the other 3, and then 1 5. So this is what? 4 times 3 times 5, which is just 60, which means 60 is their least common multiple. Okay. Subtract 1, because again, everything in there, we just need to subtract 1. So the answer is just 59. So if you try that one, 59 divided by 2, you'll get the remainder of 1. 59 divided by 3, you'll get the remainder of 2. 59 divided by 4, you'll get the remainder of 3. 59 divided by 5, you'll get the remainder of 4. 59 divided by 6, you'll get the remainder of 5. Okay, so yeah, the answer is 59. Questions? Okay, so let's move on to the next number, number 18. Given positive integers x and y, such that 2x plus 5y is 100, the greatest common divisor of x and y is 5. Find the value of x plus y. Okay, so knowing this, actually, greatest common divisor of x and y is 5. We can actually rewrite x as 5a and then y as 5b. Is that okay? Because the greatest common divisor is 5. Which means for the new, we're gonna have the new new equation. Say 2 times 5a plus 5 times 5b equals 100. So this becomes 10a plus 25b equals 100. Is that okay? So take note that you have positive integers x and y. So I think this is easy because if you look at this one, 25b, right? So when you look at 100, yeah, when you look at 100, how many 25s can you put in such that you can also add like 10 A's as well? Okay, does that make sense? So your A cannot be 0. Okay, so if A cannot be 0, then 25 is just paired with 4, right? So we cannot have B equals 4. Instead, we can have like 25 times 2. Is that okay? and then 10 times 5. Does that make sense? Because this one's 50, this one's also 50. And then when you add them both, you're gonna get to 100. Okay, so now it's very, very easy. We have A is 5, so X equals 5 times 5, which is 25. And then our Y is 5 times B, which is 5 times 2, 10. So X plus Y, 25 plus 10 is just 35. Is that okay? Any questions? Okay. Number 19. Okay. Now we're on to geometry. So how many rectangles containing at least two asterisks is or are there in the figure below? So when you say at least two, we're all gonna have like 2 asterisks and also 3 asterisks. Is that okay? So first group is this one. So we will consider this as square one or rectangle one, which means it's 2 away from the edge. This one's 2, 3 away from the edge, 2 away from the edge. And here we're just going to stop at this one because there's another asterisk there. Is that okay? So we just take these numbers, multiply them all together. Multiply the edges, the 2, 2, 2, and then 3. So that's 2 times 2. What else? Times 2 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. Is that okay? So we have 24 2 asterisks. Now we will consider 3 asterisks. Say this one as a whole. So this is 1, that's 2 away from the edge, 2 away from the edge, 2 away from the edge, 3 away, sorry, not that way, 2 and 3. And we do the same thing. That's 2, 2, 2, 2. Sorry, not 2, 2, 2, but 3. So that's what? 2 times 2 times 2 times 3, which is again 24. So this is 24 3 stars. Hold on. I made a mistake. So earlier, I only considered one group, right? I only considered like this group. Is that okay? So which means I still need to consider like this group as well. And then later on, like maybe this group, if possible. Is that okay? So we're going to consider the other group, say this one. So again, this is rectangle 1. This is 2 away from that edge, 2 away from this, 2, 3 away. So this is just what? 2 times 2 times 3, which is just 12. Okay? Is that clear? 2 times 2 times 3. So 2 times 2 is 4 times 3 is 12. So for this group, that one. So that we have 12. And then for the last pair, how do you consider this one without including this guy? Is that even possible? Rectangle containing this one and this one. Is it possible to do that? Because if not, then the final answer would just be 24 plus 24 plus 12 is 60. So that would be the answer if we cannot find another way to group them. So how many groups we have? We have this one, we have this one, and you also have the 3 of them. What else are we missing? Just 3 of them, right? This is 3 groups.
Sir,
Yo, what's up?
may go CR.
Of course, yeah.
Oh, think.
But we will continue, okay? We will not wait for you. Is that
Okay.
okay? Yeah,
Yes.
no problem, no problem. Okay. So again, since we're considering at least two, I'm just gonna read this as star, okay? It's easier to say star. So if you're considering at least 2 stars, then we're gonna have 3 stars, okay? And also you're gonna have 2 stars. So for 2 stars, we have 24 and we have 12. 24 and 12. And then for 3 stars, we have 24. So that's why the answer is 60. Is that okay?
Okay, thank you, sir.
Yeah. Okay. All right. So I think that's it for number 19. Let's go to the next one. Number 20. If a straight line 3 star, yeah. Isn't it? Hold on. Yeah, it's 2, but yeah, it is. Because you're going to consider this rectangle. 2, 2, 2, 2, 3. So that's why 2, 2, yeah, 3, 2, 2, and 2. Just still 24. Okay. Okay, number 20. Straight line L passes through points A and the slope of L is -4 in a rectangular coordinate system. Find the x-intercept. So when we say x-intercept, what's that? That's x0, right? Is that okay? X0. And then, yeah, I think this is easy. We can just do the slope formula. Y2 minus y1 over x2, x1. Our slope is -4, so we can just easily put it in there. So -4 and then y sub 2, let's pick this one. That's 20 minus y sub 1 is 0. And then x sub 2 is 7, so 7 there minus x sub 1 is just x. Is that okay? And then we can have what? -4 times 7 minus x equals 20. Is that okay? We just move the entire thing upwards. -28 plus 4x equals 20. And then we can just add 28 both sides, so we can cancel 28. So that's 20 plus 28 is 48. So x must be equal to 12. Is that okay? Questions? You have any questions? No? No questions? Okay, I think this is pretty easy. Refer to the figure below. We don't have such figure. Hold on. I'm just gonna put in the figure, okay? Number 21.
Yun lang, kung saan
Not this one. Okay, this one. Number 21. Okay, this one. Okay, there we go. Refer to the figure below, ABF. So this triangle and ADE is our right angle triangles at AED is 90, okay. This one's 90, BAF is 90 as well. Given AB is 8, AD is 15. Okay. And then AF is 6. So this one is here 6. If point C is the midpoint of BF, okay, find the area of quadrilateral CDEF. CDEF. Wait, what's that? This one CD. No, this one right here. CDEF. Okay. Is that okay? CDEF. Okay. So this triangle here, I think this is easy. So what do we want to do here actually? CDEF. The BF. So the BF should be 10, right? This here should be 10. The reason for that is this is a right angled triangle, which means you have 6 squared plus 8 squared should be equal to the square of BF. Can't write. Oh, AD is 15. Okay, not DE. Okay. So the entire thing here is this one's 15. Okay, good. 15. Again, BF, 6 squared, so that's just what? 36 plus 64. Bro, it's starting to not make sense again. Hold on, just close some windows. Stop again because it's lagging. And then I'll come back. Where's my zoom? Okay, there we go. Just like I said earlier, what was that again? AB is 8, AD is 15. This whole thing here is 15. Okay. What else? AF is 6. What else? Point C is the midpoint. Okay. So just like I said earlier, this is a right triangle, this is a right angle, this is also a right angle, which means our BF is just the square root of 6 squared plus 8 squared. 36 plus 64, square root of 100, 10. But C is the midpoint of BF, which means this is also 5 here, and then this is also 5 there. Is that okay? Okay, now here's the problem. We're looking for the quadrilateral CDEF. Yeah, this entire thing here. So how do we solve for that one? My idea here earlier was to get the area of the entire thing, and then we're just going to subtract some of the areas, some parts of the figure. Okay. AD is 15. Yep. Just remove those extra lines. So this one's 15. Not really sure how to do this one. ABF is similar to AED. Yeah, sure, because they share two angles. Oh, sorry, not two. They share this side, yeah. So ABF must be similar to AED, right? So if this one's 10, okay, if BF is 10, which is the hypotenuse, and then AD, which is also a hypotenuse, and this is 15, right? Is that okay? And then they're similar, which means there should be a ratio or a proportion between them. Okay. So when we do that, we can see that from BF, this one right here is 10. This one's 15. What do we multiply to 10 so that it becomes 15? So we multiply 3 halves, right? So we multiply 3 halves to 10 to get to 15, which means 8 times 3 halves will be the length of ED as well, which would be 12, okay? And then AE here, like the whole thing, would be 9. 6 times 3 halves is 9. But since I already have 6 here, then EF is just 3. Is that okay? So 3 for EF because the entire thing is 9. And then I need to put this one here, and then this one is 5 and 5. Also, this guy is also 5 because it's in the midpoint. Then everything here should be equal as well. Oh wait, hold on. Yeah. Okay, so what do we need? How do we get the area of the quadrilateral? So I was thinking earlier, maybe we could get the area of the entire thing. Okay, so the area of entire thing minus the areas of this triangle, say ABF. We're going to remove this. Hold on. I'm going to use a different color. So for example, the area of the entire thing. Okay, that area minus this one will be the answer. Okay, I was thinking of doing that. Okay, so actually we can we do this? Can we have this one? Can we do that? Because this one's 5, and then this one's 5, and then this one's 6, which means that the halfway. Okay, so this is 3 and 3. I'm gonna use black again. That way we can just change stuff. So I'm going to put in like this middle line here, and then this becomes 3 and a 3. Okay. So actually here, this is much easier because we can just consider like this trapezoid minus this small triangle, and then we'll get CDF. Is that better? So this trapezoid, what do we know here? So we're missing like this top here, but we know that it's just half of 8. So this is also 4. I'm going to remove the unnecessary ones. We don't need this, we don't need this, don't need this, don't need this. And we don't need this anymore as well. Do we need 5? I don't think so. We can just have this one as 6. Actually, we need 3. Okay, so again, we need 3 because of this area. That's 3 times 4. So 1/2 base times height. That's the area of that triangle. 1/2 of 3 times 4 is 6. So the whole area here is 6. Area there is 6. Is that okay? And now we get the area of the trapezoid. So the formula for the trapezoid is 1/2, sorry, base 1 plus base 2. Okay, divided by 2, multiplied by the height. Okay. So the height here is 3 and 3. So the height here is 6. Base 1 could be either 4 and 12 divided by 2. Okay. So 4 plus 12 is 16. 16 divided by 2. So that's just 6 times 8, which is 48. So 48 for the entire thing. Now we're going to subtract. So the entire thing is 48. And so the red part, which is this one right here, should just be 48 minus 6, which is 42. Is that clear? Is that okay? Any questions? What's up, Aguilar?
Here, how did you get like
What's up?
FE is 3 and the other 3 also?
Okay, sure thing. Going to write the whole thing. We just need to remember the areas 6 and 48. Is that okay? Because that's what needs computation, like the areas. So first things first, we're going to put in like this one's a right triangle, sorry, right angle as well, which is going to help us find 8 and 6 first. Okay, AF and AB are 8 and 6. Also, AD is 15. Okay, so by Pythagorean theorem, the A squared plus B squared equals C squared, we can get BF as 10. Sure thing, no problem. So this is 10, and then it also says that C is the midpoint, which means if you divide 10 by 2, then it's going to share. Like this is 5, and then this is 5 as well. Okay. And then also another property, especially of this right angle here, especially when it's connected to the midpoint, is that it's also the same distance from that one, or just half the hypotenuse as well. So it's also 5. Is that okay? So after that, what else can we establish? We can go back to the whole triangle AED. Okay, whole triangle ADE. So again, this is like a similar triangle, like to ABF because they share one side. Okay, they share one side, but we can already compare the hypotenuse. So the hypotenuse of ABF was 10. The hypotenuse of ADE from the given is 15, which means we have to scale ABF by 3/2. Okay, each of them, each of the sides to get the following. Say DE. So to get DE, you have to multiply 8 by 3/2. So that will be 12. And also 6 by 3/2. So that will be 9. However, 9 is the whole thing, right? Since 9 is the whole thing, this one is 6. This one must be 3. Is that okay?
Oh, okay. Thank you so much, sir.
Yes. And then also, the last thing that we need to consider is this triangle here. So since this is the entire thing here is 6, right? And then this is 5, and then this is 5, which means we can take the half of that one so that we can get another 3 here and another 3. Just dividing 6 by 2 again. And we can do the same thing here as well, okay, because we want to just solve for this middle line, which is just the half of 8, because this is 4 and then this is 4. And so this is also 4. Is that okay?
Okay, thank you so
From
much,
there,
sir.
yeah, from there we can just proceed with what we did earlier. Get the area of this triangle, get the area of this trapezoid, and then subtract the area of the triangle from that trapezoid. It's a bit confusing. I mean, there's a lot of missing numbers here. Like from here, it's not really like little to lacking information. There's a question here. Why not the area of ADE minus the area of ACF? Well, actually, we can also do that if you want to. Yeah, that's fine. That's good. Why is it multiple by 3/2? So we know that the BF is 10, right? We know that AD is 15. Okay. And we know that they're similar. So to get 3/2, all we have to do is divide the bigger one, 15 divided by 10. Okay. And then we can actually see that we can simplify this one as 3/2. That is why we use 3/2. Also, going back to the idea of ADE minus ACE, let's try that. ADE, what's ADE? This one. Was that again 9 and then 12 and then 15, right? 9 times 12, 54. sorry, 9 times 12 is 108, but divided by 2 because it's a triangle. So it's 54. Is that okay? So ADE area is 54. And then next, we do this one. The height was what again? 4, right? And the base was 6. So 6 times 4 is 24, right? 6 times 4 is 24 divided by 2, so that's 12. So when you subtract that, still you get the same answer, 42. Okay? So no problem. You can always, as long as you know which ones, or you can see shapes that you need to subtract, then yeah, all is well. This is even better because you don't need to use the trapezoid. Just have to use like the triangles. This is actually better. No, thank you as well. Anything else? Okay, so that's it for this number. Okay, number 22. In a rectangular coordinate system, find the area of the triangle with vertices. Okay, so here I'm just going to use the shoelace formula. I'm going to write like A, B, C, A, and then X, and then Y. So for A, that's 8, 2, B is 4, -2, -3, 8, and then A is again 8, 2. And then what do we need to do here? We need to multiply these together. So this is -16, this is +32, this is -6, right? So we add them all up. That's what, +10, right? Yeah, it's +10. And then also we do the same thing here. So that's +8. This is +6. This is +64. So all in all, this is what, 78? +78. Okay, and then we subtract them both. So 78 minus 10 divided by 2. So 68 divided by 2, so the answer is 34. Is that okay? This is again by Schuler's formula. Okay, on to the next question. No question here? Okay. Number 23. In circle O, chords A, B, and C, D are perpendicular to E and intersect inside the circle. If AE, so if this is E, they should be E. If AE is 2, no problem. BE is 6. CE is 3. Excuse me. Find DE. So we don't know what this is. Okay. So what we can form here is actually a kite. Is that okay? We can form a kite. Isn't this just 3 immediately? What do you guys think? Hold on. Let me think. So if this is a circle, if you have like something like that, 3. No, it doesn't work. So it doesn't work. Hold on. So it could be like a skewed kite, like for example, something like this, long side there, and then long side there as well. So something like that in the circle. Is that okay? So that way it will just not be equal to 3. So as you can see as well, like AB is somehow elevated upwards. So yeah, it's a cyclic quadrilateral. So how do we do this? Yeah, similar triangles. This triangle is similar to this triangle. Is that okay? Because they have the same angles here. Okay. So which means this one should be 9 because 2 and 6 and then 3 here. Again, from 2 to become 6, just multiply by 3, which means you have to, yeah. So basically it's just 6 times 2. Okay. No, 6 times 3. Which one's longer? Is this one longer than this one? Okay, so if it's elevated, then this one should be longer. So if this one's longer, then yeah. This is just 3 times 6 equals 2 times DE. Okay, so 18 equals 2 times DE, which means DE must be equal to 9. Is that okay? Oh, is it the other? Oh, yeah, yeah. Because 2 and 6 are on the same line. 2 and 6 are on the same line. So it should be the other way around. So if 2 and 6 are on the same line, you multiply them together. Okay? So 12, 3, and so D must be 4. Okay, my bad. I was so absorbed with the idea which one is the side longer? Like, is this one? Is it this one is the longer side? Okay. No, no, no. I mean this one, like this one right here. Okay, so still same thing. D. Okay, so any questions? D is 4. On to the next one. In triangle ABC, angle C is 90. Okay, it's already time. So we'll just extend for a bit. If you guys want to leave already, I cannot like stop you from leaving. Okay, it's overtime, so you guys can leave if you want to. But of course, I want to finish this. So if you guys want to stay, just stay with me. In triangle ABC, angle C is 90. So we know that this one's 90. BC is a point inside triangle ABC. Okay. PA is 30. So this one's 3. PB is 1. That doesn't look like a 1, but yeah, sure. PC is 2. Find the measure of BPC. We're looking for angle BPC. So BPC. Okay. AC is equal to BC. So this one is equal to that one. Okay, so I think it makes sense that this one here is 45 degrees, and this one is also 45 degrees, right? Does that make sense? Because AC is equal to BC, right? So this is what do you call this triangle again? Isosceles triangle. So if it's an isosceles triangle, then the angles between them are equal, which is just 45. Okay, hold on. Okay, what's next? We know that what else do we know? AP. Okay, PA. PA is 3. This one is 1. Which means we're gonna have a different way of or orienting like these angles between them. Okay, we cannot do anything else with that one. However, with PC equals 2, what does that give us? Okay, I'm going to draw the whole thing again. CAB, probably around here is the point. So this one is 1, this one is 2, that one is 3. Is that okay? Is that better? Okay. Um, BC. Is that possible? So if this is 9B, right? I think so since we're looking for BPC only, um, hold on. 3, 2. I guess so. Yeah, maybe we can consider like for example, um this one, AB. So AB is between 2 and 4. Like that side length AB is between 2 and 4. The reason for that is triangle inequality. So again, this side is 3 and then this side is 1, right? So 3 plus 1, that should be bigger than AB, right? And at the same time, AB plus 1 should be greater than 3. Which means if you move 1 to the other side, you're gonna have something like 3 plus 1 greater than AB. Of course, if you move 1 to the other side, it'd be like AB is greater than 3 minus 1. So that's what 4 AB and then 2. So again, this is not just necessarily just 3, okay? Like it could be 3.5, it could be 2.5. So this does really like give us the actual, because we're looking for angle, by the way. We're looking for angle BPC, okay? So how do we get that? Oh, what's up, Aguilar?
Sir, how did you get 45, 45 for A and to B?
Okay, so we know that AC is equal to BC, right? Like this one is equal to that one. Is that okay? Which means it's an isosceles triangle. So if this one's 90, because this is a right triangle, then both of them should share the rest of the 90 degrees, which means you're gonna 45 and 45.
Oh, so the 45 is the angles, not the what do you call it? Not the
Yeah,
sideline.
not the sideline, but just the angles.
Okay, thank you, sir.
No problem. But the problem we are gonna have here is like, how do we get the angle BPC? Any ideas, anyone? So if the point is around here again, just 1, 2, 3. Yeah, I'm gonna have to amass people for this one. Is that okay? Just for a bit. Anyway, let's just continue with the other numbers. Is that okay? Love cosines. I don't think we can use love cosines for your level, like secondary too. We can, but usually the law of cosines, law of sines is usually introduced at secondary 3 level. Okay. Can we do that? Can we use that right now? So if this was what again? C was 2, PB is 1, this one's 3. We're looking at what? BPC. So this is the angle we're looking for. The problem with that one is it really when we want to use cosine law, what angles do we have? We want 90, we have 45, we have 45 as well. I'm not really sure. I'm not really sure if we have enough angles to play with, right? Because if you look at the cosine law, that's just what c squared equals a squared plus b squared minus 2ab of cosine of what's the missing angle here? Cosine. Yeah, cosine of the opposite side. Say if this is our yeah, we don't have the angle. Okay, we don't know the angle, and we also don't know like what this is because we're missing this side. BCP equals ACP. BCP is equal to ACP. Is it? Because again, this point P here is not necessarily in the middle. So for example, if this point was here, then I don't think that's the case. BCP is not equal to ACP. Does that make sense? Because P here is a bit skewed towards B because B is closer to P. Is that okay? So it's not necessarily at the middle. So is it okay if I'll do like the next questions first? That way we'll just have a good time later with number 24. Okay, let's proceed first to the combinatorics. We'll come back to that later. Is that okay? 2 cards are drawn at random without replacement from 19 cards numbered 3 to 21. Find the probability that the sum of number of the 2 cards drawn is even. So success, excuse me. Success over total. So we want even sum, right? Even sum. Over total. Total is 19 choose 2. 19 choose 2. Is that okay? Because we're choosing 2 cards out of the 19. Right? So to get even sum, what are the ways to get even sum? It's either we're going to add two evens, right? Adding two evens. 4 plus 4, no, 4 plus 6 is 10. So yeah, always adding two evens will give us an even sum. Or if we add two odds, right? 3 plus 21 is 24. So that's even. So over 19, choose 2. So what's 19, choose 2, by the way? 19, choose 2. So that's 19, 18, 17 factorial divided by 17 factorial, 2 factorial. Cancels, cancels. 2 factorial is just 2. That cancels with that. 19 times 9. So 19 times 9 is 171. So if you want two evens, how many even numbers do we have? So we have 19 cards. We started from odd, ended to odd, which means you have 10 odd and you have 9 even. We can check 4, 6, 8, 12, 14, 16, 18, 20. Did I miss something? 16, 8. 4, 8. No, yeah, okay, there we go. 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so we have 19 even and 10 odd. So if you're choosing, yeah, so that's 9 choose 2 plus 10 choose 2 all over 171. 9 choose 2, 9 times 8 times 7 factorial divided by 2. 7 factorial, 2 factorial. That cancels, 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 cancels. 4, 9 times 4 is 36. 10 choose 2. So 10 times 9 times 8 factorial over 8 factorial 2. Cancels, 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 cancels. 45 over 171. So the answer is 36 plus 45 is 7. 81. 81 over 171, which we can still divide by 9. So 9 over 19. Is that okay? Questions? Yeah, let's move on to the next one. Oh, what's up, Aguilar?
Sir, what's the formula for this?
Which one?
For like number 25.
Number 25? This one, success over total.
Oh, okay, thank you.
Yeah, so total, which means like the number of ways that you can get two cards out of 19. That's why it's 19 choose 2. Okay, and then since we just want to consider even sum, we know that we can get an even sum whenever we're just adding two even numbers or two odd numbers. We cannot have a mix of both, right? Mix of both will give an odd result. So if you have two evens, then you have to choose like two numbers from the 9 even numbers. And then if you have like two odd numbers, then just choosing two odd numbers from the 10 odd numbers. Okay, so that is why we did what we did earlier. Okay, let's go to number 20. We can use fraction combinatorics for this, right? What do you mean by fraction combinatorics? As long as you get the same answer, then yes, sure, I guess. Fraction combinatorics. I'm not really sure what that means. Probably between 10 over 19 times 9 over 18 plus 9 over 19 plus 8 over 18. Is this it? Oh, yeah, sure. It's the same thing. So as you can see, cancel, cancel, 2, cancel, 5. Cancels as well. So that's 5 over 19. And then the other one is just cancel, cancel, 2, cancel, cancel, 4, 4 over 19. So as you can see, it's the same one. It's the same answer. So this is like the permutation, like way of doing it. Permutation, right? Because you're counting like each one. What I did was more of using combination. But yeah, as you can see, it's the same thing. Okay, number 26. How many different arrangements is or are there to arrange 3 identical black balls, 2 identical white balls, and 2 identical red balls in a row from left to right? So add them all up, take the factorial, divided by the factorial, of course, of the identical object. So we have 3 identical black, 2 identical white, and we also have 2 identical red. So that's what? 5, so 7 factorial over 3 factorial, 2 factorial, factorial. So 7 factorial is 7 times 6 times 5 times 4 times 3 factorial. The reason why I did that is so that I can just easily cancel out 3 factorial, and I know that 2 factorial is just 2 times 1 times 2 times 1, which is just 4. And then we're just left with 7 times 6 times 5, which is 30 times 7, 210. Is that okay? Okay, so let's take a look at number 27. Hopefully this is straightforward. Number 27. Find the probability that the product or results of rolling 2 fair 6-sided dice is a multiple of 3, but not a multiple of 9. So when we say rolling 2 fair 6-sided dice, probability, so it's still success over total, okay? So the total is what? Probability of the product, okay. So it is just 6 squared for the total, because we're rolling 2 fair 6-sided dice. A multiple of 3. So when you say a multiple of 3, one of the dice could be 3, right? So that would be what? 3 for the first one. It could be 2. Okay, 3, 2, 3, 4, 3, 5. Okay, does that make sense? So how many are they? Um, 1, 2, 3, 4 times 2. So this is 8. Is that okay? So 8. And then multiple of 9. So when you say multiple of 9, which means it has like 2 threes, right? That is why we are not including 3, 3. We're not including 3, 6, because that would be through 2, yeah, 2 threes already. And then also we have 6, 1, 6, 2, 6, 4, 6, 5 as well. So again, that's just 8. So that's 8 plus 8. Only 3 and 6, right? Has the number 3 as a factor. So this is 8 plus 8 is 16 over 6 times 6 is 36. Divide both by 4, so that's 4 nines. Is that okay? Any questions? Let's go to the next one, number 28. Given x and y are positive integers such that 3x plus 2y equals 55, find the largest possible value of xy. Okay. If you want to get the largest possible value of x and y, hold on. Someone's unmuted. Again, if you want to get the largest possible value of x, y, we have to make sure that x and y are like close together, right? So, for example, if we take the extremities, like what happens if 3 times 1, okay? If x is 1, then what will happen to y equals 55? So if you use this one, you get 2y equals 52, which means y must be 26. Okay, so which means our xy in this case will be 1 times 26, which is just 26. If we use the other way around, I'm just showing, okay, what will happen if we use small numbers. 3x plus 2 times 1. That doesn't really make sense because 53 is not divisible by 3. So we have to use the other one, say 2. 3x is equal to 51, which means x is 17. So in this case, our xy is 2 times 17, 34. So it's still relatively small. Okay. So what do we want to do? We want to like make sure that it's in the middle or something. All right. Let's consider how middle are we talking about? So we can actually divide 55 by 2. That will give us what? Not necessarily equal, but you have 27 and 28. Is that okay? 55 is equal to 27 plus 28. So from here, we can easily see that, hey, 27 is 3 times 9. And then 28 is 2 times 14. Is that okay? Does that make sense? So yeah, 3 times 9. So which means our x here is 9. And then our y is 14. So 9 times 14 is easily 126. Is that okay? Any questions for number 28? So you have to make sure that our terms, our x and y's are close to each other. So 9 and 14, they're not really close, but it's better than the gap between 1 and 26, right? It's better than the gap between 2 and 17 as well. Does that make sense? So 9 and 14, they're relatively close, which means bigger product. Okay, number 29, how many integers from 1? Can we use AMGM inequality? AMGM inequality is referring to arithmetic mean, right? So for example, if you're considering x and y, AMG inequality, is it like this way or this way? I always forget. So x plus y over 2. Okay, so it's this way. Okay. So AM, arithmetic mean, is always greater than or equal to its geometric mean. Okay. Arithmetic mean meaning you're going to add two numbers, say x plus y over 2. Okay. And that is always greater than or equal to the geometric mean. So if you're having only x and y, so that's the square root of x times y. Is that okay? So if you want to, you can get like x plus y over 2. Like you square this one. And then this will be like the answer for your xy. Oh, okay. So actually, it's not really the case because this is minimum of xy, like greater than or equal to. Does that make sense? So this one will give us minimum, actually, if we're referring to like to mean xy. I think that's why it's not. Because you don't even know what our x and y is at the first place. Does that make sense? So that's why AMGM it's only rarely used, especially it's only used like, for example, if you have multiple terms, multiple integers, because it's easier to compare that way. Okay. So of course, if you have 3 terms, then this will become what? X plus y plus z divided by 3, and then x times y times z, and then take the cube root of that one. Okay. So of course it changes the more we have numbers. Okay. So as you can see here, it's using minimum. It's yeah. If you're saying that this is the right way to do it, then yeah, this is minimum. Okay. Is that okay? Does that make sense? Okay, going back here. How many integers from 1 to 1000 are not divisible? Are not divisible. Okay, so this is the opposite way of the usual thing. Okay, so actually let's first find how many are divisible by 2, 3, or 5. Is that okay? So let's do that. 1000 It's lagging again. Hold on. Okay, so again, you're going to do divisible first. We're going to take a look at not divisible later. So that's 1,000 divided by 2. Okay, take the floor, or I mean round down. 1,000 divided by 3, round down as well. And then also 1,000 divided by 5, round down as well. And then of course we subtract the ones where it's like what they call this, the intersection of numbers. Say for example, the intersection of 2 and 3, that would be 6, right? The reason why we're going to do this is because we want to not double count, okay? And then we also have, what else? 3 times 5, this is 15. And then we also have 5 and 2, actually, subtract. Just 10. And then finally, we add back also their intersections, 6, 15, and 10, which is, what's the LCM? 6, 15, and 10. 30, right? 30. Okay, 30. Okay, so what does that look like? 1,000 divided by 2, that's 500. Plus 1,000 divided by 3, that's 333. 1,000 divided by 5 is 200. 1,000 divided by 6. So it's probably half of 333, right? That will be 166. Minus 15. What's 100 divided by 1,000 divided by 15? Probably 66, right? Yeah, 66. And then 100 divided by 10 is 100. 1,000 divided by 30 is just 33. Okay, now let's add 500. So this is what, 400? No, 340. No, 334. This one, we can add these two guys first. So that is just leave us 300. Does that make sense? And then this one will give us 100. So all in all, that's what? 734. So this is divisible. But again, we wanted to solve for not divisible, which means we just subtract that one from 1,000. So the answer is 266. Is that okay? Questions? Okay. So last one. There are 100 cards. Numbered from 1 to 100. If you randomly draw one card, what is the probability that the draw number is a multiple of 6 or 8? Sir, y plus on the last one, 1,000 divided by 30. Lord. So earlier, okay, I'm just gonna go back for a bit. So the 6, the 15, and the 10, these are like the intersections, right? Of 2 and 3, 3 and 5, and then 2 and 5. Okay, so we're removing those double counts. Also, the reason why we're plussing this is because we're also removing the double counts of 6, 15, and 10. Okay, we don't want to like subtract too much as well. Does that make sense? Here we are worried of adding too much, that's why we are subtracting. Afterwards, we're worrying about, hey, are we subtracting too much? That's why we're adding again. No problem. Okay, number 30. 100 cards. So again, this is probability. So success over total. All right. So how many numbers do we have actually for multiple of 6 and 8? So from 1 to 100, there are 16 sixes, multiples of 6, right? Mults of 6. 96 being the highest. 6 times 16 is 96. And then for 8, 12, right? So 12. 12 multiples of 8. Out of these numbers, you also have 2 multiples of like, what do you call it again? 6 and 8. So 48. Actually, no, 24. Hold on, 24. So 4 multiples of 24. Is that okay? So it's almost like the same thing earlier. So something like 100 divided by 6, take the floor of that one, plus 100 divided by 8, take the floor of that one, subtracting 100 divided by 24. Does that make sense? Again, this is 16, this is 12, and then 4 of that one. So that's 28 minus 4, so that's 24. So success is 24 over 100. And so the probability is, yeah, 24 100. Just simplify that one. You could answer 24% if you want to. That's fine. Or I'm bad. Okay, 6 over 25. Yeah, 6 over 25. Yeah, no, yeah, this is the lowest form. 6 over 25 or 24%. Is that okay? Okay, but still, we have the any questions? So I think that's all, like from 1 to 30, except the other one. Except which was that one? Where's that one? Yeah, except for this one. So if you want to stay, you can stay. Again, we're done. Yeah, except for this one. What I wanted to do was just add a solution for this video. So make sure to watch the recording. Okay. Other way as well, I was thinking like maybe I can pause this recording. I'll just come back when I'm ready to solve for this one. How does that sound? Is that okay? Is that fair for you guys? I'm just gonna pause the recording and then hopefully I'll come back and give you the answer for this one. Is that okay? All right. So again, I'm just gonna pause the recording. Okay. So actually one of you helped me out answering this one. I was able to answer it by myself, but my solution was a bit too lengthy. It was involving you know, considering C as the coordinate 0, 0, and then A as 0s, and then B as s0, and then P as xy. So as you can see, it's going to be lengthy. Like I'm going to use here the distance formula because we know that this is 1, this is 2, and this is 3. So we're going to use the distance formula, and then so on. We're going to use the cosine law. Okay. However, one of you, unfortunately, I don't know how to pronounce the name. Let's just call him Neil. He pointed out that we can actually rotate the whole figure. When we rotate the whole figure, well, actually, he just wanted to rotate triangle BPC. Yeah, he wants to rotate it. He wanted to rotate that angle on C. But for me, what I did was I rotated the whole thing. Uh, still on C. The reason for that is now we can clearly see like what will happen. Okay, so our point P, it's no longer point P. Let's call it like point Q. So we know that this one's 2, right? So which means this one is also 2. Okay, and then if we try, so it's not perfectly like rotated, but we can actually form another right isosceles right triangle here. Okay, so when we do that, we know that this angle right here is 45 degrees as well. Okay. Now that is important because that is actually also um gonna help us finding BPC, because BPC, like this 45-degree angle here, will be the same if we actually did another triangle over here. Okay. So this is still within BPC. Is that okay? So that's another 45 degrees. Actually, it would have been better if you reflected the triangle like downwards, because then we'll still be staying at BPC. But anyway, same idea. And then also, what we're missing is basically this part right here. Okay, and then altogether, that's just the same as the angle BPC right there, right? So the thing is, since we rotated the whole thing 90 degrees, then we do know, okay, we are very sure that this is also 90 degrees, okay? Because we rotated the whole thing 90 degrees. So all in all, this is, again, 45 degrees and plus the rotation that we did, which was 90 degrees. So therefore, the measure of BPC is 135 degrees. If you want, you could also answer in radians. This will be what? 3 pi over 4, right? Radians. Okay. So yeah, I think that's it. Doable. I chose to show this one because it's quick. It's visually helpful as well. Okay. All right. So I think that'll be it for me. Yeah. How do I